electricity. So what is electricity? The flow of charges per unit time, that is nothing but I equal to Q by T. I equal to Q by T. So I equal to current, and Q is the charge, and T is the time. T is the time we can take. Now charge. So what is charge? Charge is nothing but it is the property associated with matter which can influence the presence of other charges. So once again, charge. What is charge? It is the property associated with matter which can influence the presence of other charges. So SI unit of charge is coulomb. SI unit of charge is coulomb. And property of charges. What are the property of charges? So we know properties. We can take properties. Properties of charge. So opposite charges or unlike charges attract each other. Suppose you can take positive Q and negative Q. So charge. Then both will attract each other. So whereas positive and positive will repulse each other, negative and negative will repulse each other. So this will attract because opposite charges attract each other. Similar charges will repel each other. Similar charges will repel each other. So then next one, types of charges. So what are the types of charges? Types. One is proton. So positive charge is proton, and negative charge is electron. Negative charge is electron. And next one charge of proton is, so charge of proton if you take plus 1.6 into 10 power minus 19 coulomb, whereas negative charge of the electron is 1. So minus 1.6 into 10 power minus 19 coulomb. 1 coulomb of charge, 1 coulomb of charge is equal to 6.25 into 10 power 18 electrons. 10 power 18 electrons. Okay, so that is about the charge of the proton and charge of the electron. We can go for next one, potential difference, and we will discuss the potential difference and electric current. Potential difference and electric current. Electric current. Okay, so what is the potential difference and what is electric current? We can see work done. First point here, work done by a source to move charges in circuit is called potential difference. Work done by a source to move charges in circuit is called potential difference. Charges, so charges will move from positive terminal to negative terminal to positive terminal. So that is nothing but potential difference. So electric current, you see the flow of charges in the circuit is called electric current. The flow of charges, the flow of charges, okay, per unit time in the circuit is called electric current. Second point is here in potential difference. The potential difference between 2 points is defined the amount of work done in moving a unit positive charge from one point to another point. So, what is the potential difference? The potential difference between 2 points means, so we can consider this is A and this is B. So potential difference, second point you can consider. So the potential difference between 2 points is defined the amount of work done in moving a unit positive charge from one point to another point. That is potential difference. Whereas in electric current, you can see the amount of positive charge flowing through a particular area in unit time is called electric current. The amount of charge flowing through a particular area in unit time, amount of charge. So as I already said, I equal to q by t, I equal to q by t. So in that case we can take the example. And third one is potential difference V equal to work done by charge. Work done by charge. Potential difference V equal to work done by charge. Whereas third point you can see I equal to Q by T. So formula you can write I equal to Q by T. Yes, fourth point is SI unit of potential difference is volt. SI unit of potential difference is volt. Here, electric SI unit of current is ampere. SI unit of current is ampere. Then we can consider one more. Sixth point we have to discuss. So actually, here it is fourth point only. Fifth point we will discuss. Here it is fourth point only, right? So this is the fourth one, and we will discuss now fifth point. So fifth point is here. One potential difference between 2 points in the circuit is defined when 1 joule of work is done to move a charge of 1 coulomb. So normally we can take. So by seeing the formula we can define. So what is the formula? So work potential difference formula. Potential difference formula you see. So what is the formula here? Third point. So V equal to W by Q. V equal to W by Q. So 1 joule of work done to move a charge of 1 coulomb. For 1 volt we can define. 1 volt we can define. So 1 joule of work is done to move a charge of 1 coulomb. A charge of 1 coulomb, that is 1 volt. So whereas fifth point in electric current, 1 ampere of electric current is defined. 1 coulomb of charge flow through a given area in 1 second. So same formula you can see. 1 ampere of current is defined. 1 coulomb of charge passing through given area in 1 second. So that is 1 ampere equal to 1 coulomb per second. 1 coulomb per second, that is the fifth point. And coming to the sixth point is, coming to sixth point you can see, here is a sixth point. Potential difference is measured by voltmeter. Potential difference is measured by voltmeter. What is the device used to measure a potential difference? Voltmeter. Whereas in electric current, the current is measured by ammeter. The current is measured by ammeter. Ammeter. And seventh one you can see. Voltmeter is connected parallel in the circuit. It should possess high resistance. Voltmeter we are connecting in circuit parallel combination. We are connecting parallel combination. So whereas seventh point is ammeter we are connected in the circuit. It will be in series combination. So we are connecting in series combination. So these are the differences between potential difference and electric current. Potential difference and electric current. Then we can go for the next one is Ohm's law. So Ohm's law. So the relation between potential difference and current. So what is Ohm's law? Ohm's law is the relation between potential difference and current. So now we will discuss. So as you can see the differences between potential difference and electric current. Now we can go through it. So what are those? Ohm's law, relation relationship between 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 potential difference and electric current. Potential difference potential difference and and electric electric current. So Ohm's law. So Ohm's law we will derive. So what is Ohm's law? Ohm's law is nothing but the potential difference V across the ends of a given metallic wire in an electric current is directly proportional to current flowing through it. So normally, so we know the circuit. So this is a conductor you can consider. So current is passing through it. Suppose I am taking the current here. So current is passing through it. Okay. So across the conductor, we are connecting the voltmeter. We are connecting the voltmeter. So the definition is the potential difference. So this is a potential difference. P is the potential difference. The potential difference across the given metallic wire in an electric circuit. Here you can take resistor because across the resistor only the potential difference can be identified. An electric wire, so is directly proportional to current flowing through it. Directly proportional to current flowing through it at constant temperature. So potential difference is directly proportional to current flowing through it at constant temperature. At constant temperature. So this is very important. So V equal to IR. So I will give the shortcut way to remember. So that's fine. So you can take remember this triangle. So you can consider V up, V here, and I here, and R here. So from here V equal to IR. From this R is a resistor, no, proportionality constant. R is the proportionality constant. Proportionality constant, because directly proportional, right? That is the reason we are taking R is a constant. So from this we can take V equal to IR. V equal to IR. So from we can take I equal to I, if you want, I equal to V by R. I equal to V by R. Then R equal to V by also V by I we can take. So these are the formulas for electric. That is nothing but Ohm's law. Next one, resistance. Next one we will see the resistance. So what is the resistance? Generally, resistance is nothing but the phenomena of resistance is nothing but resistance. Resistance is nothing but the phenomena. It is a property of a conductor to resist the flow of charges through it. Means the phenomena of opposing the electric current in an electric circuit, that is known as resistance. SI unit of resistance is ohm. SI unit of resistance is SI unit. We can take a SI unit is ohm. OHM. Ohm symbol is ohm. We can take. Then we can take 1 ohm. 1 ohm. How we can take? How we can define 1 ohm? How we can define 1 ohm? How we can define 1 ohm resistance is defined as the potential difference across the two ends of a conductor. The potential difference across the two ends of a conductor is 1 ohm, 1 volts, and the current through it is 1 ampere. Means we can take 1 ohm resistance. 1 ohm resistance V equal to IR, right? From that equation we can take current through a resistor is inversely proportional to its resistance. We know the formula V equal to IR. So current through a resistor is inversely proportional to its resistance. So from this relation we can take I is inversely proportional to R. Okay, so accordingly we can take it. Then resistance of Y depends on. So now we can take resistance resistance of wire depends. Resistance of wire depends on what? On what it depends, we will discuss. So resistance of wire, it depends on length of the conductor. R is directly proportional to L. R is inversely proportional to area of the conductor, and it is nature also we can take, or temperature also. So resistance depends on temperature also, and the nature of the conductor. Fourth one, nature of the conductor also we can consider. Next one, so R equal to R is directly proportional to L, R is inversely proportional to 1 by A, R equal to rho into L by A. So what is rho? Resistivity. Rho is the resistivity. SI unit of, so you can take rho, so rho equal to, you can consider rho equal to RA by L, RA by L, rho equal to RA by L. What is SI unit of resistivity? This is very important. 3 marks question will come. I will explain this one, how to find out the resistivity SI unit of resistivity, how to find out. You can consider, normally you can take R equal to rho into L by A, right? So rho equal to RA by L. So we know what is the SI unit of resistance ohm, and SI unit of area is meter square, and SI unit of length is meter. So here you can cancel meter and meter square, then the remaining is ohm meter. So SI unit of resistivity is ohm meter, ohm meter. Okay, so the symbol is ohm meter, like that we can consider. So that is about the resistivity and resistance. So then we can take care about one more thing also, that is nothing but resistivity. About resistivity we will discuss about resistivity, resistivity, and remaining topics we will discuss in the next class. We'll complete this one. Otherwise, resistivity, resistivity. Okay, resistivity. So resistivity. So now the formula. What is the formula? Rho equal to RA by L. That is nothing but R equal to rho into L by A, right? So you can take cross multiplication, then you will get rho value. Rho equal to RA by L. So this is a formula. Now we can see resistivity of a conductor is equal to. So now you can see the formula. R equal to rho equal to RA by L. Resistivity of a conductor is equal to resistance of a conductor of unit length and unit area of the cross section. So the resistivity of a conductor is equal to resistance of a conductor of unit length and unit cross sectional area. And resistivity does not depend on length and area. The cross section means resistivity rho does not depend on physical dimensions of the conductor. Physical dimensions, that is nothing but length and area. And resistivity depends on nature of the material. It depends on nature of the material. Nature of the material. Material it depends. And next one, resistance and resistivity both are depends on temperature. Resistance and resistivity both are depends on temperature. Okay, so that this is about resistivity. So I of course we covered all the points. Once again you can see here, this is about resistivity. And next one, SI unit of resistivity, ohm meter, and the differences between so here we discussed about resistance depends on and watt factors, and next one relation Ohm's law, next potential difference and electric current, and next one, so this is about our electricity topic. So in the coming video we'll discuss more about this one. Thank you.